Quite possibly one of the most distinctive features of the big data landscape, compared to other segments in the tech industry at least, is the oversized role that open standards and software such as the Apache Foundation play in accelerating innovation. The challenge, well, at least for me, but I also imagine for other businesses, is to wrap your mind around the huge body of open systems to understand how it all comes together in a coherent whole. The other concern I often have is the assumption that open often means incomplete, at least in terms of the sort of enterprise features that you might require, especially when it comes to things like governance and controls. Well, today's guest, along with their co-author, has just published a book that addresses these challenges and more in a way that blends technology mastery with business outcomes. Welcome to another episode of the AI Forecast, proudly sponsored by Cloudera. I'm your host, Paul Muller. Join me along with leading companies and industry experts as we explore the past, the present and the future of data and AI in the enterprise. And today I'm joined by Dipankar Mazumdar, co-author of Engineering Lakehouses with Open Table Formats, published by Packet. He's also co-author of Apache Iceberg, the definitive guide by O'Reilly Publishing, and is heavily involved in the industry in his role as a developer advocate for Cloudera, which is how we managed to meet. Welcome to the podcast, Dipankar.
Thank you so much, Paul. Thanks a lot for having me as well. I'm super excited about this.
Yeah, we're really excited to get into it too. But before we do, we warm up every show with a little thing we call the Fast Four. Are you ready to play the game?
Yes, absolutely. Yeah.
Let's do it. All right. What would people who know you best, it could be your family, it could be your work colleagues, it could be both, what would they say is your superpower, Dipankar?
I just think that I've never been asked that before. And I think I'm just it's a wide scope, way, but, also given that I probably don't have too many superpowers. But I think one of the things that I kind of personally think is that I kind of translate complex system into clear mental models, if you may. In my role across different roles that I have had in my career, I spent a lot of time taking deeply technical architectures, ideas, and breaking it down to the engineering for the personas and the architects and leaders that can actually make sense about this, right? So I think that could be one of my thing that it's extremely, let's say there is an extremely tough complex stuff that you need to break it down into a more granular, simpler stuff. I may have some ideas around that, how to do so.
Well, having just read your book, I can agree with you on that.
Thank you.
The most impactful technology of all time.
Wow. Yeah, I think given that we are in that wave of AI and everything, I think it just kind of forces you in a way to talk a little bit more about API. But I think I'm going to take a different direction here. I think the most impactful technology for me, probably it isn't a tool or a new wave. I mean, waves will come and go, I guess. It's probably one of the core fundamentals of software engineering, which is abstraction. We saw this with SQL. We saw it with databases, right? Going back to 1970s and 80s, right? I was reading this paper by this researcher called Edgar Codd. He published this paper in 1970, I believe. It's basically how do you talk about this relational thing about tables and databases and stuff, right? And now we are seeing that same, again, abstraction thing coming into the play with AI, right? Even general people, for example, people who, I think I should elaborate. By general people, I mean people who are non-AI developers or non-developers in a way. And because in my role, I only interact with developers, so that becomes a general thing as well. But even with people who are not involved in technology, with ChatGPT and other mechanisms coming in, or even non-AI developers, they don't think about models or GPUs or, those kind of thing anymore, right? We are thinking in terms of what could be our best prompt, right? To get me an outcome to something, right? Some of the AI developers are thinking about agents and outcomes around that. So I think all of this that is being enabled, that enables a general person like my dad or my mom to even talk with AI, is that abstraction. And I think that is one of the most impactful thing in the whole world of technology and in the software engineering world, especially.
Yeah, I couldn't agree with you more. I think it's a really,
right.
I've never thought of abstraction as a technology, but I think even if you think about algebra to a degree, algebra was kind of
exactly.
Was 1.0 abstraction. It was
right.
It's only gotten better since then. That's a really cool thought. We talk about AI. You've just mentioned AI. We talk about what it's going to do for business. We're just about to. I want you to forget about business for a while. I want you to think about what you'd like to see AI automate for you in your future. Get selfish for a little while.
Yeah, I want to. Like, honestly, the one thing that I constantly think about is how do I get my day-to-day chores done, like, in a way, right? That allows me to, like, think a little bit more about other things that I want to think about. For example, when I was writing the book myself, I was like, oh shoot, I could have spent some more time, in this part. If I had something else to like do this day-to-day chores of mine, right? So the small repetitive things, those planning, those reminders, organizing, coordinating, I think kind of like in a way, if you want like me to like materialize that, maybe I want like kind of a AI life admin, if you may. And once you experience that, it becomes very obvious why the kind of the same idea applies to work as well, right? And then you rightly mentioned that at work we are already seeing this coming up, right? And we are already seeing coding agents and whatnot take on our responsibilities, some part of the responsibilities, right? And when AI removes that friction, I think human gets the time and the mental space back for the thinking, the judgment, and creativity. Ultimately, I think we can be only creative as humans, I guess. There are scope for AI to also like think a little bit more around those. But yeah, would love to see some of the automations being taken care, even at the very like high level, like, doing some kind of chores for me, like, and I'm seeing this commercialization happening right now as well. I think I was seeing some kind of robots being like commercialized that can do your dishwashing or whatnot, like putting your dish in the dishwasher or something. Yeah.
I don't want to burst your bubble. It's probably the most common answer we get to that question on the show in the last 60-something episodes has been, I just want something to do my chores for me.
Right. Exactly, yeah.
Last but not least, you work with data every day quite clearly. You think about these problems a lot. What are some of the best practices you've learned as someone who works with data every day? What are some of the hacks you've learned that make working with data better for you?
Just to elaborate a little bit, my background, like I obviously came as like a software engineer, like, at that point of time, it was more about building systems. I know that those are scalable and, kind of like, for example, one of my first client was like a US healthcare, like insurance company, right? So all that mattered was like how we can support those insurance like initiatives and like, filing and all those things. So very early on, right? And then I switched into data eventually. And then I'm seeing like different best practices coming around. How to work with data, personally identifiable information and all those different things, right? GDPR perspectives as well, some countries have. But I think, again, like I go back to the fundamentals, right? I think there are a few things that stand out. First, always design for change. Like, your schema will evolve, your requirements will shift, and, systems that assume kind of stability, they break first, I would say, like in my experience. So I would highly recommend to think about those perspectives. And I'm going to talk a little bit more about that in our detailed discussion later. But I think, design for change is one of the first principles that I've always followed. Second, focus on making data interpretable, not just queryable. Like if people can't easily understand what the data represents, like, they won't really trust it, no matter how fast or accessible it is. And there are different ways to do that, right? At one point in our industry, we had humans doing labeling and stuff, right? And now, thanks to AI and then, the greater initiatives and things like catalog and lineage and those kind of thing, we now have more solid tools to kind of help us do that, right? So definitely like being able to make data interpretable is a really important thing. And finally, don't optimize too early, I would say. Like, when I say optimize could be do different things. Like there are cost optimization, performance optimization, different things, right? A lot of the people that I interact with in my role, are building data platforms and data architecture for AI, right? So I usually say like, get correctness and trust right before chasing the performance part, the cost part. So I think these are some of the things that I typically like look forward to when I like take a new initiative of like building something from scratch.
Yeah, I think I like that idea. Especially, it's one of the questions I had for you is how do we think about going from pilot into production and what are some of the things we need to think about? So I think you've already addressed some of those questions, but maybe I come back to them again later because it's an interesting topic. Tell us a bit about what inspired you before we talk about what inspired you to write the book. What inspired you to move into developer advocacy?
Yeah, well, I mean, a lot of people, and I don't know like how much you are like, I don't know if you interact with a lot of developer advocates or like, people who are building developer functions. But, you would pretty much like see this role coming up now, especially for the people and for the companies that are building this kind of developer-focused products, right? I think that's where you need a developer advocate. Well, and just a little bit of history there, like, developer advocates were used to be called developer evangelists at some point in time. Apple was actually one of the first companies to do so, right? And like very early, like software evangelists, they were called 1980s even, like to that extent, like helping people understand what an Apple platform can do. And then Microsoft brought in with Steve Ballmer and, other people like taking this active role as well. So when I first, my journey has been that I did my bachelor's and master's in computer science. My initial like jobs were into software engineering, like I said, building systems using different kind of like programming languages, Java, C++ and stuff. Then I moved into, at some point in 2016, I guess I got like to hear about Hadoop and the big data world coming in, like, and how you are kind of like dealing with this massive data set. And I was always involved in like mathematics and the crunching part of the data as well. So I'm like, I took an opportunity that gave me to, build this kind of data pipelines in the very first place. And I'm talking about 2016, 17, the timelines. At that point of time, and just to mention Cloudera's name here as well, because Cloudera has been, such a leader in the open source world. And I actually learned a lot myself from Cloudera's resources, like to be honest, completely honest, at that point in time in 2016, 17. So, and then eventually I took in different roles like data visualization, machine learning, data science came into the play as well. For a moment, I actually paused my career, my professional career for 2 years or so. In 2019, I actually like moved from India to Canada to pursue my master's in computer science focused on AI. So I decided, like, I was applying a lot of algorithms and I was like, I do not know the math behind it, which doesn't really make sense for me. Because, Python as a language, for example, gives you a lot of way to like just call a library and do your stuff, right? Again, abstraction into play, right? So that's the same thing. But then I also needed, as an engineer, I needed to like go and do my homework myself. So I was like, I know visualization, I know machine learning, but I do not know the depths of AI and the mathematics behind it. So I, ended up like getting a master's in computer science. I did my research-based course, which is like thesis focused. I had to write a thesis. And my area of research was called Explainable AI. So basically, I built a solution. Yeah. I built a solution that enables you to like load a model. For example, let's say an AI algorithm has refused your bank application, a loan application, let's say, right? Now, the algorithm, to a bank employee is just black box, right? But they need to understand the nuances towards it. And how do I make it more white box in nature? So the tool that I built actually can load this model and show you how the decision was actually made through a visualization. So that is actually how I actually ended up being more closer to the community, because I open sourced that thing and I was writing a lot about it and publishing papers around it, and people were genuinely curious. That was a segue to even like, changing countries and coming to Canada. And right after I graduated, I took an opportunity like that allowed me to be, they were like, well, we do not have a software engineering role. We have a developer advocacy role. And I was like, what do you mean? Like, what does it mean? Like a developer advocate? So I did some research. I went back in the history. I was like, wow, this looks pretty interesting and pretty close to what I've been thinking as well. So yeah, that's how I got into developer advocacy, by going into and doing different sort of things.
And it looks like you're having a lot of fun just looking at you've got a personal website, obviously, where you talk about some of your other book and your writings, whether it's related to some of the standards work you've been working on, or alternatively, even your speaking engagements. It looks like it is a great combination, as you say, of applying your technical mastery, your communication, right, but also I suppose you get to live vicariously. You get to watch what other developers are creating and get close to that. It's a lot of fun.
Exactly. You got it right. Exactly. And just being closer to the community when I initially was like involved, I was like, that sense of feeling was something very like important for me. And now that I get to do that in a day-to-day basis is amazing for me.
It's brilliant stuff. So let's talk a bit about the book, Engineering Lakehouses with Open Table Formats, which prompted a couple of questions. First question that I had, as someone who's only partially technical, I used to be technical many years ago, what is a lakehouse?
Right. Well, it's a fascinating idea to be honest. Like, to build a lake house. Like a lot of my writings, a lot of my talks are like, how do I build an open lake house? And that openness part is also part of that lake house as well. So yeah, we're not talking about obviously like, amazing lake houses, that you can build in, here in Canada where I am.
Somewhere to go fishing.
Right, exactly. Yeah, or it's probably like we take that idea in a way, but the whole idea of a lake house is basically like I would not even complicate that this much. It's not a completely new thing. I keep on telling people. Over the years, we have had databases, right, and different sort of databases, right. Now, each of the databases vendors, like what they are, for example, if we talk about MySQL, Postgres, any kind of database vendor like Oracle or Microsoft, what they typically do is they kind of make imagine these are the Lego pieces, right? There are file formats, there are storage engine, there is the compute engine. They bundle all of this together into one monolithic system and they call it a database, right? And there is this, like I said, there is a compute engine that is responsible for processing the data. There is a storage, which is where your data is actually being stored in a database. There is a storage engine that is ultimately managing the data that is there in your storage system, right? So all of these are bundled together into one system, right? Now, this was great. People worked with this system for over a while. Then we move into like more of analytical systems. So there were databases for transaction, which is like, let's say you do a flight booking. You insert a row in your database, right? That's a new flight booking. But when you're talking about analytical workloads, that's where you needed specialized kind of databases called online analytical processing, which is an analytical type of databases. That's where those are also like typically called as data warehouses. Companies like, and vendors like, for example, like, Snowflake or, Redshift. There are different technologies that came in.
When I started, it would have been Teradata, for example, was the
Teradata, exactly.
Yeah.
Exactly. You got it. Yeah. So Teradata was a common one as well. Like, so the whole idea is that it serves as a centralized repository of some sort and you run your analytical workloads on top of that. Now, the reason we didn't go with the transactional databases at that point of time is because analyticals are like equations are more aggregation, like sum of something, like count of something, maximum of something, right? So to do aggregations on that sort of like row level transactional workload is very hard. It's going to be very slow. So this online analytical processing or OLAP system that we used to call, they actually enable people to like, build like more analytical applications like BI reports, dashboards on top of that, right? So this is a journey from data online, like transaction processing from like relational databases to data warehouse.
All very structured data.
All very structured data, exactly. And the things have changed a little bit now, obviously, like, with different vendors and like different technologies coming in. But at that point of time, there was no way to like deal with unstructured data or like semi-structured data like JSON, for example. So then people were like, okay, let's build like a data lake. So that's where the Hadoop and the entire ecosystem of data lakes came into the play. And they became like a file system where you can dump all of your data, whether it's structured, semi-structured, doesn't really matter. Images, videos, it doesn't matter. And companies, obviously, they want to like, monetize from the data, right? Because they're collecting this data overall. So data lake was great. Like, you could dump all of these things, right? And do your analysis on top of that. But, without even going to the details of thing, it led to a lot of complications and things. Like, for example, one, you needed to have specialized set of engineers to work with the data that was residing on a data lake. There was something called MapReduce algorithms that only specialized Java-based engineers could implement, right? What about my data scientists? What about my data analysts who only works with Python, for example, or SQL, for example? They didn't have a way to work with the data itself. Ultimately, what people were doing is they had the data lake, but they were still exporting a subset of it to a data warehouse for their BI and workload. So ultimately, it's a two-tier architecture, right? You have a data lake, you have a data warehouse now, and there is cost to managing them both. There are a specialized set of engineering resources being hired. At times, you're duplicating the data. You're taking a subset of a copy. You don't even know how to manage the subset of the copy. So there is this like long set of problem that I can go on and on about. And personally, I've seen that in my different role as data engineers and and software engineer as well. And then basically the industry took a different approach where they were like, well, let's think about a cohesive architecture where you bring the best of a data warehouse, bring the best of a data lake, and merge it into a form. Obviously, we are not just thinking about very high level merge, but in a way, it's kind of like bringing the best of the both. So data warehouses actually had great data management capabilities, like things like compaction, clustering, optimization, right? Those were already inherently present. Data lakes didn't have them. So we brought the data management capabilities from a data warehouse. Data lakes, on the other hand, like you said, it can store any sort of data. It's more flexible. structured, unstructured didn't really matter, right? So you took the best of the both world and came up with architecture, which is the Lakehouse architecture. Now, the most important thing that I want to kind of drive our attention towards is the open table format, which is a part of that Lakehouse architecture. And this is the part that actually makes the Lakehouse open. And that's why I'm using the term open here. Because going back to our example of Microsoft and Oracle, all these different vendors who kind of made a monolithic system, now imagine it's more of a modular system. So you can basically keep your data as an open and independent tier, and you can bring your compute, whether it's your whatever, whether it's your machine learning based workload, whether it's a BI based workloads, you can just plug it to the data rather than bringing data to the compute, right? So it's the other way around. So that's in a way the segue to Lakehouses and open table formats.
Now, that's a really, really a great description of it. And I have to say, within the first kind of chapter of the book,
right,
you and your co-author do a really great job of taking something that is often filled with a lot of vendor speak,
right,
and you explain it in really, really clear terms about exactly that. So it's even the first chapter, I was learning some new things. So tell us then, because a lot of books have been written about the individual topics, about Iceberg, about Flink, about Hadoop. There's so many books out there about it. What inspired you to write engineering lakehouses with open table formats? What was the driver?
And to be honest, I should mention how I was lucky enough to even get a chance to work in this open table format space at the first place. This is back in 2021, right, when I was with a different organization. And at that point of time, my focus was primarily open source, which is like Iceberg, right? In 2021, I was going to conferences speaking about how engineers should care a little bit more about Iceberg. And people were like, well, why do we need something like that? Why do I need a new technology like that, right? Like with any other technologies that you would expect, right? Because we have the data warehouses, we have the data lake. So it was very hard. In a way, it was very hard for us to initially show them the value prop of it, right? And come to where we are today. Every vendor, every organization is going hard on Iceberg, Hoodie, Delta Lake. It's just it have taken the entire data architecture world, right?
But if I can interrupt you for a second, from a non-technical perspective, and again, I'm technical enough, but I'm not that technical. If one of the things, and I mentioned this in the opening, one of the challenges I find in dealing with the data community is if every month it seems like there's a new standard, a new initiative, some sort of new project being developed. And the first challenge I face as a business person is should I care about this? What's it going to do for me? And is it going to complicate things, or is it going to simplify? Is it replacing something, or is it adding to it? It does feel like it's a bit of a minefield. And one of the things I like about the book is it helps put all of those things into context.
Yeah, I definitely see your perspective, and I obviously in my role also speak with decision makers and people who do not necessarily code every day in their life, of course. But I think to your point, the standards, right, and they are super important, right? We have come to a point where we have been able to decide as a community that Iceberg is going to be the standard for open table formats or for open data architectures, right? I think that standardization, or even for the matter, other technologies that I can name is Apache Arrow, for example. I want to give a shout out to Apache Arrow here. A solid technology that came out of, if you know Pandas, for example, the whole data science world was revolutionized with Pandas. It was co-created by Pandas creators as well. It basically serves as an open source standard in every software engineering platform in data, whether you're moving data across systems, across vendors. It is just an enabler, right? So I think defining those standards was super important very early on. And we were able to luckily do that, and we had some really strong support from the community as well. Some of the names, if I can take, for example, Apple was a huge proponent of Iceberg from very early on. Cloudera, for example, have been invested with Iceberg from 2021, right? As a vendor. And there are other vendors in the space as well who help to kind of solidify those ways, right? Because ultimately, and to your point, if you're not building towards a standard, you're going to end up building so many proprietary things, so many different things, that most of your time is going to be about integrating those technologies with your platform, right? Whereas if you can define a standard, you just agree upon that, right? I think that's a super important part. Now, coming to the point of how we even decided. So again, my co-author, he was at Apple and he saw these problems firsthand as well. He just joined OpenAI to work on similar problems and did architecture solutions as well. And we were talking casually in general, in general of our problems that we see. like I said, in my role involved, I'm involved in conferences, speaking there, meetups, organizing things as well. So I spoke with a lot of people in general. Since the time I wrote the first book on Iceberg, the discussion was like, can we get a cohesive book that compares this Iceberg, Delta, and Hoodie, all these different technologies under one umbrella, but also like shows like a guiding, like kind of a framework for engineers to decide on what to select from these different table formats and how does they integrate with these different technologies, like you said, with Spark, with Splink, and Hadoop and ecosystem as well. So I think that was one of the main reasons that we decided, okay, it's time for us to like write something that compares all of these different things, but also touch upon some of the various newer things that we were bringing in. Like, for example, catalogs is a completely new thing. Interoperability techniques like with Apache Iceberg. So those are some of the things that we are kind of tackling with the book, and that is completely new in our work.
Yeah, and as I say, if the thing that strikes me going through it is it explains, I think, quite clearly how all of those various standards come together to solve a business problem. And I love the fact that there's a quiz at the end of every chapter to make sure that you're actually taking this stuff in. It's very cool.
Right. Yeah.
So tell me about some of the common misconceptions teams have when adopting Lakehouse architectures, because I think this is, your first one's often the toughest one, right? It's where you do a lot of your learning. So what are some of the misconceptions teams have when they get started?
And I think definitely like at the forefront, I want to mention like there are two parts of like Lakehouse architecture, right? One is obviously you can take these modular pieces and bundle them yourself. If you have a great engineering team, you can build up all of this stuff yourself, right? I mean, like I said, it's a standard, it's an open standard, right? So that means you are going to end up with a similar kind of architecture if you just bring on these different Lego pieces and build up your architecture, right? But there are also vendor platforms, for example, like Cloudera or any other vendor platform for that sake, that lets you like get started from day one and be up and running, right? So there are different aspects to building Lakehouse architecture. But irrespective of what, I think one of the most important thing is like once you get into your journey of Lakehouse, people often do not realize that the next phase is the hardest, which is like, how do I make sure my Lakehouse formats, my Lakehouse tables are performant, right? So I think performance optimization, cost optimization, ability to apply things like clustering, compaction, Z ordering, all of these different techniques that are very mathematical and that has helped our industry over the years, how those are being tackled. Because like I said, in a pre-Lakehouse world, if you had a data warehouse of sorts, your data warehouse is going to manage all of these things that are lying underneath, right? And bring your data up to in a certain form that is really performant for your compute engine, whether it's AI, BI, or whatever it is. But now with the Lakehouse, because we are in this like very early phases, I should not say we're in early phases, we are in a phase where we are all experimenting towards things, but also like some of the companies have already productionized things, right? So I think the most important part comes in how do I make my tables functional? How do I keep them optimized? Both from a storage perspective, both from a compute perspective. If you work with AI today, you will know that context and APIs are super critical. Otherwise, your costs are going to go super high, right? So how do you make sure you have the relevant context and relevant things for your AI workloads, for your BI workloads? I think this is the thing that people often miss, that they, sometimes I see, okay, we are going with the Lakehouse and everything is operational. It just goes on and on. Once you ingest your new data, once you have piles of data coming in, your data lake is now no more just terabytes, it's petabytes and zettabytes and whatnot. That is when you see this actual crack in your architecture, right? As in any kind of architecture, whether it's your houses architecture, whether it's building architecture, any kind of architecture, right? The scale, the latency, the cost are super important.
Yeah. Are there some choices that you make early on that you could potentially regret later? Are there some obvious, maybe not obvious, but there are maybe some common anti-patterns that people adopt that we could talk about just to help them avoid them?
Yeah, no, absolutely. I think one of the main challenges that you deal with this Lakehouse format, especially if I talk about just batch workloads, right? You are still good kind of like in a way because, you're writing data at a very slower pace. Versus if you're talking about streaming system, for example, that's a completely different story. So the way, and the book also like covers a little bit more about how you handle these different sort of workloads. But for streaming based workload, for example, the whole idea is that as soon as you get data, you write the data, right? And these are mostly like smaller, like chunks of data. Imagine like Uber Eats, right? You order something, right, on Uber Eats. and you order something that itself is a data, right? Then you add a tip to it, that's another set of data. To your delivery driver, I mean. Then you update your order with something else, that's another set of data, right? So these are very smaller chunks of data that needs to be frequently written and managed. The problem is, if you are going to store all of this data in a storage system, you are going to end up with a lot of small files, right? So the more number of small files you have means your compute engine has to read those small files many number of times. Versus if you collate them into one single big file, your compute engine can just read one file at the same time, right? So I think that is one of the things that people usually miss, specifically if I talk about Iceberg and streaming in that context and in a perspective, that how do you deal with this kind of streaming-based workloads, right? So I think the first thing would be like understanding your workload type, whether it's a batch workload, whether it's a streaming workload, whether you are going to get a lot of late arriving data, for example, right? I can give an example based on the work that I've done with Uber's engineering, for example. Uber engineering team, they basically they used to get a lot of late arriving data because Uber driver tips are always paid later on, right? Yeah. So you still need to make a total payment addition, right? How much was the total paid money, right? Now the problem is if you get your data once to your system, you need to rewrite that entire set of the petabyte of data to just update that single file level updates, right? And I'm talking about at scale, you're doing it for multiple files, right? Multiple drivers. Now, how do you make sure it's only incremental, that only you get the deltas and then write those same, right? So these are some of the things, that nuances that you have to care about as you make the system productionized and operational. So understand the type of workloads, whether it's batch, streaming, define your workloads accordingly. Think about your performance optimization techniques, like I said, like clustering, compaction, Z ordering, all of these different techniques. And more importantly, think about the business value out of that, right? Ultimately, you cannot expect that, okay, I have adopted Lakehouses and that's going to make my business insights, super relevant. You have to work towards that, right? The data modeling and all those foundational aspects still remains the same, right? Whether it's a database, whether it's a lakehouse or whatever. That is another aspect that I would definitely consider in terms of the misconception team might have in general. Yeah.
Yeah. No, I think that's, and we'll get to the business thing in a moment. I suppose what I'm hearing, and I don't want people to take this the wrong way, is to a certain degree, you're almost always in this perpetual pilot mode. And what I mean by that is it goes really back to your comment you made earlier, design for change, don't assume stability, is you need to get something out there and start testing it with the business or business value. But as the system changes, you need that schema to be robust in the face of change, because you'll learn something through piloting. You need it obviously to be backward. Is that basically it?
Exactly. I mean, you hit it to the point. And I would like to definitely mention here that one of the core ideas with open table formats like Iceberg and Delta and Hoodie was that changing schemas. It was super hard to evolve schemas, evolve partition in data lake systems, right? If you just have a Parquet file, it's just super hard because they're immutable in nature, right? So you cannot just go and change a particular column in a file, in a Parquet file, right? So it's super hard. You have to rewrite that file over time. So I think this is one of the most important aspects that people try to understand. And I think that is super critical, yeah.
Well, especially when you rub it up against a DevOps model, which says, let's iterate quickly, smaller chunks.
Exactly.
And the business is saying, oh, let's add a column, or let's add let's do something different. The developers are all saying, no problem. And then the Lakehouse folks are saying, yeah, we can't do that. Unfortunately, the table structure is rigid. You're going to break the business. Right. We need to now do a giant extract, reload. It's going to be incredibly fragile compared to agile. Would that be a good characterization of it?
Yeah, I would definitely say that the whole idea with the Lakehouse was to address that part, and I think honestly, this is one of the main reasons towards having something like evolvable system, right? So yeah, definitely Iceberg and the table formats have addressed this part until now, and I cannot even recall the number of times my leaders, when I was a data engineer myself, have asked me to hey, we got a new source of data, a new set of columns. You have to, incorporate them. And the only way for me at that point of time, when I was not having a lakehouse, was to rewrite that entire set of table, which you can imagine at scale can be expensive, right? So with a lakehouse, you don't even have to think about rewriting those stuff. It's a simple add column, update column, delete column. Those kind of things are there.
I want to talk a little bit about, again, just talking about some of these architectural choices before we talk about business. Well, I'm about to talk about business in a strange way because I'm going to talk about cost. Right. I think one of the challenges that we have at the moment with these elastic environments is it's very easy, especially I found using AI tools like Claude to help me code. Claude's really good at helping me be productive in getting the business outcome, but sometimes I look back at the bill I'm getting from my cloud provider and I'm like, whoa, I'm using a lot of resources here.
Yes.
And, I'm storing a lot more data than I thought I would, or I'm using a lot more compute than I thought I would. And I then have to spend a lot of time, I'll use a technical term, refactoring my solution to try and get optimization back in there. What's been your experience or thoughts on how you address this issue of, and I think you even mentioned it, focus on the data quality, focus on getting the business results and worry about performance later. How do you find that balance? Because you can create some really significant business challenges cost-wise if you're not careful.
And I think we are hitting that point now, like to your point, I would say we are still in a very exploratory phases right now. Like one of the things that I usually talk with like my friend circle and the people professional in the space is they're all trying to balance between, Cloud can help me build this stuff, but I'm going to end up spending this much of money of my organization, right? So that right balance, I think, and we are still in the very early phase of figuring that out as well. The way to think about that is, again, like there are two perspectives. Obviously, like, there is this organizational, like cost saving perspective, which I think is super critical. You should not discount that part. Ultimately, they add up to a lot of money from R&D perspective, for engineering perspective. And I think that is super critical. At the same time, having that, I think it goes back to my initial mention of the term context and context engineering in that matter, right? We need the right set of context for our right set of AI model, right? Mm-hmm. So if I let my AI agent just imagine I'm doing like an agentic pipeline, right? So let's say I have a multi-agent workflow where I have 2 agents deployed, and one of the agents' responsibility is to go check my Iceberg tables and figure out whether my tables are healthy. Going back to my performance optimization point, right? Whether my tables are even like healthy, whether do have a lot of small files. At this stage, I would definitely like segregate out into 2 parts, right? One is the like, okay, how do I give it the right set of tool for the agent to explore that, right context, right? So this could be, whether it's a document, whether it's a completely new tool via MCP or something like that, right? Or even like a knowledge base of a company or even the knowledge base of a open source documentation, whatever it is, right? So I guess the whole idea, and I was reading this blog from Anthropic as well, like quite recently, about how you can save like context engineering costs. Ultimately, it's about limiting that, making it a subset of that entire domain, right? For example, like, so if I talk about Lakehouses, Lakehouse, like I said, it's a storage system, it's a database of sorts, right? It has structured, unstructured, semi-structured, all kind of data, right? Now, if I make my AI agent to work with my Lakehouse data as the main context source, I need to think about what are the right set of tables for this particular query that I'm prompting, right? For example, like tell me about the tables, like I said, which are healthy. I have to be able to specify or point to the right set of table, right? From a business perspective, if someone goes and asks like, hey, I want to build a dashboard, like, based on, my sales trajectory over time, right? Like a time series analysis chart that I want to understand over the past 6 months, right? Now, if you give access to that entire set of like your Lakehouse, you're going to end up burning a lot of your credentials and cost. Exactly. Yeah. So I think this is where, again, like I can like probably bring in, since we are already in the technical depths of it, but this is where things like catalog, adds a lot of value here. Okay. So I think, something like a cataloging tool that can understand the right set of lineage, right? Okay, this is your query, the natural language query. It gets translated into certain embeddings of sort internally, right? Those embeddings, how do they find out that these are the right set of table? And this all goes back to my thoughts about labeling, about lineages, marking the right set of data. Ultimately, these are all going to help and shape us, become more aware of, becoming more cost aware and think about like, because I think we have enough compute now. Like we have a lot of compute, if I think about it, right? Going back to a time when, 1990s, when neural networks like, deep learning, for example, couldn't even grow because of the sole reason that there was no compute, right? And now we have the abundance of compute. It's just a matter of for us to like kind of restrict us from not spending too many around that. So right set of context engineering is a huge part of that. Lakehouse can be it's a huge part of your context engineering, but catalogs, lineages, and all those things makes it super important.
Now, you introduced the topic of lineage and we talked a bit about the business. One of the things I loved about the book is it finishes with, I can't recall now if it's 1 or 2 business case studies, for want of a better term, that encourages the reader to apply everything they've learnt in the previous chapters to some real world business problems. Why was it so important to you that you introduced business? Because normally developer books don't talk about business. They're very purist.
Yeah, I'm just, going through the books, at this point of time, I'm like, okay, there are real world applications, there are learnings, there are hands-on examples. But I see the point around real world applications, right? I think that's where you were heading towards. Yeah. I think one of the most important part was like, because this is a completely like at that point of time, or even at this point of time, when people are thinking about Lakehouse, and just to clarify, like the book is primarily for people who have solid understanding of databases. They have worked probably with data warehouses in the past. They are, kind of picking up new things and around lakehouses and these data systems. So I guess for me, it was like, I need to be able to like tell them a story and relate to the technological aspects of thing that they have been already like doing in their job already, maybe, right? But they're probably going to replace that data warehouse model with a data lakehouse. They're probably going to replace some X with some Y, right? So I think what I did, and when we decided both of us, like we were thinking about how we can make sense of a story around that. So we still decided like to keep it like at a very, like some of the common stories that people would typically see. Like for example, we had a story of a manufacturing site that are using these technologies to like build newer stuff, right? So for example, like finding out better product market strategy, better product availability, and all this kind of thing. So I think we kind of tried to relate it with the exact technical bits of it, with the value that people are going to end up being those decision maker, right? I think that was one huge part of, and we knew it very early on that we had to do something like this because
it's very cool.
Yeah, I think there is no other way, because ultimately you're solving for business, and I think a new technology should be able to point you to that same problem just by the way it is kind of executing that, right? So that was the whole idea. Yeah.
Now, the other thing that I didn't expect to see talked about too much in a technical book, and maybe it's because I don't understand the standards as well as I should have, is there was a lot of talk about governance and lineage, topics that are really important to business, especially when it comes to managing risk and compliance. I can see you nodding. Why is that such an important part of the Lakehouse today?
It would be a miss, like, if we just think about the technological aspects of thing and not talk about security, governance, and all those different things that I mentioned. Honestly, when we decided, like, when we were kind of like jotting down the chapter's idea, this was actually brought in by my co-author, who actually had implemented these things at Apple and, in different organizations, Uber as well, like, and different, from a different organization per se. And even going back to my journey as well, I predominantly didn't work on the security governance area, like at least when I was like, a data engineer myself as well. But I think this is one of the most important thing, that if we kind of miss it's not going to make sense overall, right?
Well, and it's hard to put it back in if you didn't build it in from the start.
Exactly. This had to be like baked in as part of the story, right? There is no compromises to security, governance, and lineages and all those different sort of things. And I want to reiterate, like, irrespective of whether you're using a simple Excel file as a database, or even like a database system or a lakehouse system, very like technical like lakehouse system, you need to have that security principles in place, right? I think that is super important. We added it as a bonus chapter in a way, like the whole goal was like, how do we make sure people understand that this is also a critical part of it, and we are not discounting that in any form. I don't think necessarily the principles changes in terms of like the technological aspects, like the same technological aspects you would have seen in like a data warehouses. For example, like let's say role-based access management, right? Kind of like, you define a role. Let's say you are an administrator, right? You have access to these tables, right? In a data lakehouse. This wasn't different in a database. You had the similar thing, right? As an admin, you can do your own stuff. As a developer, you could do your own stuff. As a business leader, you can have access to something else, right? So the foundation of it remains the same. the way how to do it in a lakehouse, it's something that we introduce in the book. And I think that should be a little bit more beneficial as well.
Agreed, absolutely. All right, well, we're going to wrap up now. I've just got a couple of questions as we do. First question. I've read your book. I've gotten excited. I've started building a lakehouse and a system. What are some of the first operational pain points that you think teams are likely to hit as they go from proof of concept into production? What would you anticipate?
And again, this goes back. I mean, we have discussed so much about like the starting point itself. Like, this goes back to my initial point around you cannot just think about like just productionizing Lakehouse and adopting Lakehouse. You have to think about your data is going to be in a continuous form being ingested, right? That process is not going to stop, right? So how do you balance your ingestion with your ever-growing data in your data lake storage? For that, you need the right set of optimization mechanisms, right? And this can be something that you take it from open source world, like with Apache Spark. Iceberg provides a lot of, kind of open source, like standardization, optimization techniques. But also like with vendor platforms, for example, like even I can speak for Cloudera because, and again, I've been here for a limited time, 5 months only. But at least some of the things that I've been able to like see it myself in action is like, when does a table become less performant, right? How do I count those? How do I keep a track of all those tables that are becoming very hard for us to manage as we get from POC to that production step? So these are some of the things that are being built. And it's not just Cloudera, I would say, like in general, like the industry is building towards those standards. So I think it's a matter of understanding that you are building your lakehouse. I mean, the whole reasoning of having a lakehouse in the first place, I'm assuming, is that you have a lot of data coming in and it's coming in varied form, right? Whether it's structured, semi-structured, unstructured. So I think it's important that you understand that this is not just your ingestion, like your first few tables, it's going to be very like ingestion heavy, update heavy, very transactional. Like I said, schema changing, at some point you will have a lot of schema changing. These schema changes are ultimately going to make impact in your AI pipelines as well, because, your AI pipelines are being fed from the same data as well. So how do you think about those aspects? The one thing that I didn't touch much about is the interoperability perspectives. The reason we have an open like connotation with the table format and lakehouse is because, like I said, the data itself is open, right? Now, imagine you created a Cloudera native Iceberg table. The whole idea of that is that you are not just restricted to Cloudera now. You can bring in any kind of compute here, right? We enable that via standards and specification. So if you are a vendor platform building today, think a little bit less about how you can log people in versus think about how you can make your data more interoperable between different teams and stuff. I think that's a very important point because in larger organization, you usually see this kind of data silo problem. And I think if you agree on a standard like Iceberg, you have to make sure the data itself is more interoperable. And the way to do so is very much laid out in the community via these specification mechanisms and stuff.
We've also talked a bit about the future of AI and how it's going to evolve or co-evolve with the Lakehouse. What do you see as some of the evolutions happening in the world of Lakehouse architectures when it comes to supporting GenAI?
The one thing we are leveraging AI is like, it's twofold. One is like Lakehouse for AI, and the other is AI principles or AI, stuff getting implemented within data Lakehouse, right? So one thing that I already touched upon is the context part, which is Lakehouse for your AI, right? Which is models are powerful, but without the right context, like I said, you are going to end up in a lot of like, calling irrelevant stuff that you probably wouldn't need for your agents and stuff, right? So trusted data, history, metadata, and state, those are going to be super important. I think agents cannot reason or act reliably if you don't have those mechanisms in place, right? So that's where Lakehouse architecture become critical because you have now a shared foundation, a shared governance and truth, and you can reason over that. And also, most importantly, because it's built on open formats and open standards, different tools and engine can now work on the same data, right? Because imagine like if you worked with like, agents and MCPs and workflows around that, your MCPs are basically in a way like the tools, right? And APIs. So you need to be able to like let your agent have access to different set of tools, right? The only way to do that is by kind of like solidifying on this idea of open formats, right? So you can call tools, query data, coordinate actions in open way instead of being constant. Like imagine if you had an agent who is just constrained to only one particular set of data and have access to nothing else, right? Can it make a reliable decisions and make a judgment as a human? Whereas we as human would go and explore different sorts of, data set we would have in our, whether it's a Google Drive or whatever it is for a particular sales. So I think Lakehouse is going to be extremely critical, and it has all the right primitives to be that kind of context source for AI agents and workflows.
Wrap up for the management audience listening, people like me. What's the one architectural principle they should be insisting on when talking to the developer teams in the next 12 months when they're thinking about Lakehouse?
I had different thoughts going on in general, so I kind of thought a little bit about that. I think the biggest opportunity, obviously, in AI, as we have realized until now, is the leverage, right? So for business people, it's important that the task that's where, like I said, I'm a business guy. I need to, make a dashboard out of my data that is residing in some kind of a storage system, right? At one point in time, it would involve significant engineering effort, if I may, to even collate data and bring it to a centralized repository, building ETL pipelines, spaghetti ETL pipelines, doing a lot of stitching and ingestion in between as well, which I think at this point of time, we are in a very good shape as business decision makers as well to do those things by ourselves, given we have the right set of architecture for us to support that model, right?
Yeah.
And Lakehouses are exactly built for that kind of model. And I personally see, I have a lot of hopes in general, and I advocate a lot about that as well, that we are going to end up seeing a lot of business folks do a lot of the tasks that were at some point seen to be heavily engineered themselves. And the way, to get support around that through developers is by getting the right set of context and right set of data sources. So I think that's where kind of the Lakehouse is going to be super critical as well.
Okay, focus on the data, as always.
Yes, as always.
Good data equals good decisions. There you are.
Right.
I think we've got a show title. Hey, Dipankar, there's been absolutely great having you on. Where can people go to learn more if they're interested?
Oh, yeah. I mean, in general, I think so. Cloudera community is something I would highly recommend. It's community.cloudera.com. This is a site where we have a lot of new technical blogs coming in from both engineering teams, from my side, developers. We are building it for the persona focus, right? For example, data engineers might have some concerns. Data scientists, machine learning engineers might have something to read about. So all of this is going in community.cloudera.com. And I'm also super interested, in general, to talking with the people in the community. So I think that's a very good avenue to start a discussion, chat, and all those things around that.
That's brilliant. Awesome. Well, that's a wrap. If you've got questions or comments from today's episode, we'd love to hear from you. Drop a line in the comments section or hit up Cloudera or LinkedIn, on LinkedIn, I should say, using the handle @Cloudera with your thoughts. Thank you so much, Dipankar, for joining us.
Thank you so much for having me.
It's been great having you on. We've also got a great array of guests coming up. So if you've enjoyed today's episode, make sure to like, share, and subscribe so you don't miss another drop. Thanks again to Cloudera for hosting another episode of the AI Forecast. And thanks again for listening in. We'll see you all next week.